All right, guys, welcome to today's distance learning day. Today we're going to intro our next unit, Unit 3, which is on quadratics. The notes for today, everything I'm going to talk about are available on campus. I attached it to the actual assignment, so if I were you, I would open that up in Notability. If you have the option to use two screens where you can view this video on one screen and take notes on Notability on the other, that would probably be the most effective way. So before we talk about vertex form, which is a certain way to write a quadratic equation, we got to talk about the most basic, the parent function for a quadratic, which is the equation y equals x squared. We're going to take a few minutes to talk about what that looks like, what characteristics and features it has, and then kind of go into transforming and moving it around. So if we had no idea what y equals x squared looked like, we could always set up a little table of values, an x and y, just like we did with piecewise functions. And we could pick some random numbers, let's say 1. And plug in 1. 1 squared is 1, and 2 squared is 4, 3 squared is 9. But if I plot those points, so 1, 1, 2, 4, and 3, 9, it's actually not a straight line. So what's happening before that? So maybe if I plugged in 0, 0 squared is 0. And then if I plugged in negative 1, negative 1 times negative 1 would be positive 1. And negative 2 squared would be 4. And negative 3 squared would be 9. So I end up getting a graph that looks like this. And if we connect those points, it actually resembles a U-shaped graph. And a U-shaped graph is going to be anytime we graph a quadratic. So a couple things with this U-shaped graph that I want us to know. One second. First of all, this bottom point right here is called the vertex. That is the most important point on the graph. It's a point we have to show every single time. Also, running vertically through this graph, I'm drawing this little dashed line. This dashed line is called our axis of symmetry. And the axis of symmetry in this example is at x equals 0. And what the axis of symmetry does is it makes sure that every point on the right side, so let's talk about like this point right here, that point's 2 units away. So it reflects or mirrors 2 units away on the other side. Whereas this point up here is 3 units, so it reflects it over 3 units. This makes the graph symmetrical. Now, when we talk about a quadratic, the left side and the right side go on forever. So our domain is negative infinity to positive infinity. And our range, the very bottom of this graph is at 0, 0. So the y values are 0 and up, so 0 to positive infinity. This is our most basic equation and graph for a quadratic. So what we're going to do now is transition and start to look at when we have different numbers plugged in. So vertex form of a quadratic is this equation, y equals a, x minus h squared plus k. So there's a couple notes I'm going to give you. First of all, if our a value is greater than 0, the graph is going to open upwards. And if a is less than 0, so if a is a negative number, the graph's going to open down. If the absolute value of a is greater than 1, we're going to have a stretch. If the absolute value of a is less than 1 but greater than 0, we're going to have a shrink. But the most important thing in vertex form is that the vertex itself, the most important point on the graph, is going to be at h comma k. Now, h and k are in the formula, but here's what you have to remember. H is opposite, and k is the same. So if we know something's in vertex form, we could take the opposite of the number inside of the parentheses and the same number is outside the parentheses and put them together, and that is the vertex. So with these couple questions here, the goal is to state the vertex. So what we're doing is just saying the opposite of this number, which is -2, and the same as this number, which is -3. The vertex is at -2, -3 in example 1. In example 2, the opposite of this number is +4, and the same as this number out here. Well, there's no number out there, so we could actually put a +0 there and it wouldn't change anything. So that means our vertex is at 4, 0. Number 3 is kind of unique because there's no parentheses, which sort of throws us off. So remember, we could rewrite this as y equals 2x something squared plus 7. What could I write right there that wouldn't change the problem? Hopefully you're thinking +0, which means the vertex would be at 0, 7. So when you're missing, if you're missing h or k, use 0. What I want you to do right now is pause the video, and I want you to try 4 and 5 on your own. I just need you to write what the vertex would be. All right, now that we can look at an equation, realize that it's vertex form, and write the vertex, I think we're going to be ready to graph. So for this first one, our vertex is at -2, and it's missing k, so we're going to use 0. So I'm going to go right to -2, 0, and I'm going to plot that point on my graph. Now the vertex is where the graph changes directions. So that means I'm either going to have a graph that looks like this or a graph that looks like this, right? And if we can think back to what we talked about at the beginning, if the a value is positive, the graph's going to open up, which means my graph is going to look like this. But how many graphs could I draw that open up? Well, here's 3 really quickly, right? So we got to find out another specific point, but what I'm going to do is I'm going to immediately draw the axis of symmetry right through that vertex. And I'm going to write AOS x equals -2. The x value that we use is always the x value of the vertex. Okay, to get a second point, we actually have to do a little bit of work. So what we're going to do is we're going to pick an x value 1 unit away. So this is a note you would want to write. Pick an x value 1 unit away from the axis of symmetry. So in this case, the axis of symmetry is -2. So pick a number 1 unit away. So either go 1 to the right or 1 to the left. I'm going to go to x equals -1. And I'm going to plug that into the original equation for x. And now I have to follow the order of operations. So exponents are first. Parentheses are first. And then we're going to do our exponents. And then we're going to multiply. Which means when I plug in -1, I get -2. So that gives me an ordered pair that's on the graph. So -1. I'm sorry, I wrote a -2. These should all be +2s. I don't know where that came from. So quick little mistake there. All right, so -1, +2 is a second point on our graph. And if we know that the vertex is at the bottom there, we can reflect that over the axis of symmetry to get a third point. And now, as best as we can, try and draw a U-shaped graph through those 3 points. So our graph now has a vertex at -2, 0, a point at -1, 2, a point at -3, 2, and an axis of symmetry. That's everything we need for the graph. Last thing, domain. It goes left and right forever, so all real numbers. And the range is from 0 up to to positive infinity. All right, number 2 is the last problem we're going to do together in this video. So first thing is the vertex is at -1, 2. So I'm going to plot that right away, -1, 2. Right away, I'm going to draw the axis of symmetry through that. And the AOS is at x equals -1. Now I'm going to pick a number 1 unit away. So I'm going to pick 0. So I'm going to say x equals 0. And I'm going to plug that into the original. And I'm going to do parentheses first. Then I'm going to do my exponent. Then I'm going to multiply. And then I'm going to add 1/3 plus 2. 1/3 is 0.33 repeating. So I'm going to write this as 2.3 repeating, which means when I plug in 0, I get 2.3 repeating. On my graph, that's at 2 and a little bit above 2. So it's kind of tough to show here, but it's right about here. So that's 0, 2.3 repeating. And when I flip that over, I'm going to get -2 and 2.3 repeating. And now my graph's going to look like this. So it's still a U-shaped graph, but it's a lot wider. So if you can think back to transformations, we would call that a shrink. And that's because that 1/3 out in front is between 0 and 1. The domain here is -infinity to positive infinity. And the range is going to be from 2 to positive infinity. Again, this 2 that we're using is the y value in the vertex. Last thing in the video is I am going to have you try number 3 on your own. So after you try number 3 on your own, you're going to submit your notes. Now there's 3 problems total that you should have completed on your own. Okay, so I'll be checking those with the online submission. So your submission should be all the other questions filled out because we've done them together. On top of that, you'll have 3 problems that you're trying on your own. It's okay if you make mistakes. Those will be the 3 problems we check at the start of class next time we meet.